Okay, here's a review for test number 3. Also, you can use it for the retest. First question, is this a function? You want to check to see if the x values repeat. Obviously, they do repeat right here. Therefore, this answer is a no. Now, you know domain. Anytime you see domain, you want to think x values. Anytime you see range, you want to talk y values. So my domain goes right here, and all you got to do is just list the values one time. Minus 4 and 4. Bad handwriting, bear with me. Pen's acting up a little bit. State the range. The range is going to be the y values. So clearly you can tell there are 3, 5, 7, and 9. Easy questions. Next one, number 2 says, is this a function? Once again, checking the x values, see if they repeat. They do not repeat, so this is a yes. Domain is going to be -2, -1, 0, 1, and 2. Your range is going to be 4, let's go, 1, and 0. That's messy, so I'm going to write it again. 0, 1, and 4. Just write it one time. Your next one's going to be what we call, is this a function? Check the vertical line test. Let's switch colors so everybody can see it. Touches once, touches once, touches once, touches once. That line got a little crooked, sorry. But you get the point. So this is a yes. State the function. The domain is how far left. Notice that's an arrow. So that means it's going to go to negative infinity and it's going to stop on 2. That point is 1, 2, 3, 4, 5, 6, 7, 8, 9. So he's going to stop on 9. X values got to have a bracket, must be parentheses here. Range, how low does it go? Don't let this confuse you because this arrow goes down forever. So he's minus infinity. How high does it stop? It goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, there it is. And notice that's always open parentheses, nine's a bracket. State the end behaviors. End behavior is always up or down. Where is it trying to go to? You must write left hand end behavior is negative infinity. Right hand end behavior, notice it stops. So it stops at 1, 2, 3, 4, 5, 6, -7. Where is it trying to go to? Look at this guy here. Is this a function? Yes. How do you know? It passes the what? Vertical line test. Touches it once. State the domain. Domain, what do you think? X. How far left? Negative infinity. How far right? Negative infinity. Sorry, positive infinity. Because no matter what, as this thing runs left, it continues going up. Range. How low does it go? 0. Bracket it. How far up does it go? Forever. Once again, end behaviors are up, down, up, down. What's it doing on the left? You must give me left hand must be infinity. Right hand must be infinity. Quadratic flip. So now what you're going to do here is you're simply going to do a quadratic flip, left 4, down 9. So you know your parent function is going to be f of x. You know it's got to be x squared. So put in squared. We're going to go left. Ran out of room. Let me sneak it right here. F of x, you got to name that function, equals parentheses x minus 4 squared plus 9. This is a 4 right here. Remember, this negative sign right here means the opposite. Up, down is always positive. Don't want you to get confused here. Let me go ahead and erase it because somebody's going to be tripping. So let me go ahead and erase this. Oh, sorry. Grab the eraser. Erase this guy. Make it nice and pretty. And we're going to call that a 4. Cool. That also gives you your vertex. Remember that letter is H and this letter is your K. Linear function. Mother function, f of x, which is we call a parent. Right 8. So you know you got to go x minus 8, keep it in parentheses, plus 10. Sorry. That is a minus 10 because it said what? Down, right? So now let's go back and get that minus sign. Be careful here. Make sure, no, since this is not squared, you can clean this up and it can turn into x minus 18. All right, looking good. Now what we're going to do real quick is I'm going to go ahead and save this guy here as a file. Okay, cancel that out for a second. Let me pause and save that and I'll come right back. Now we're ready for page 2. Right here, absolute value. You know that's the absolute value of x is the mother function. Let's make this pen a little bit thicker. Alright, that's a little better. You know, so it's going to be f of x equals absolute value x left becomes plus 2 plus 5. Got it. Cubic. You know, he's got to be f of x equal something's cubed. So he's got to go right, so it's opposite. Cube it. And we're going to do minus 9. Quadratic, you know, that's x squared. Notice the vertex, it makes it very nice for you. Hold on, let's get this quadratic right here. F of x equals what? X minus 6 squared minus 9. Absolute value, f of x. So you know you got to have the bars. Opens downward means this is a negative sign. Vertex, just opposite, x plus 4 plus 3. All right. So that makes sense. Now, here comes when people get crazy. Get away from that calculator. You know what a linear function looks like. Simply a graph. Anytime you want to find the y-intercept, you stick in a 0 for x. So y equals what? So now that gives me y equals 4. So you can put your dot 1, 2, 3, 4 right here. My slope is what? Up 1 over 1. Bear with the graph. And there you go. You can also find your x-intercept by simply putting in a 0 in for y. So that means x equals negative 4, which makes sense because that's what it's going to cross right there. Translations, all you have to do is say vertical shift up 4. Domain, negative infinity to infinity. Just write it one way. The range is negative infinity to infinity. Cool. Quadratic. Find your intercepts first. Y equals everywhere you said x squared goes to 0. So you know that's a minus 6. 4, 5, 6. Be careful. You know I'm going to be picky. You know it's going to go up, but I want to know where it's going to cross at. It's going to cross at your x-intercepts. I say x-intercept. You plug in a 0 for y. So that gives us x squared equals 6. Take the square root, take the square root. X is equal to plus or minus 2 point something. You really don't care. You just want to make sure you can get it to go between those 2 points right there. Pitiful graph, but it makes it, whoa, that's ugly. Let's back that up. Now that makes sense because now you can get very precise without a calculator. Make sure you make this little curve, make it prettier than mine. Y equals x cubed. Do your quick sketch. Let's undo that real quick. That quick sketch looks something like this. Right? Keep the curves. Got it? You know you're going to have a shift, a vertical shift or 2 up. Right? You know you're going to have a... So now once again, find that y-intercept. Stick in a 0 for that x. What I like to do is just draw through anything that has an x, so that becomes a 2. There it is. The question is, where does he cross that y-axis at? I'm sorry, the x-axis. So 0 equals x cubed plus 2. X cubed equals negative 2. Remember, you can take the cube root of a negative number. We know the cube root of negative 2 is roughly negative 1 point something. We don't have to get precise. You just want to know that you're going to go between negative 1 and 2. So there it is. That's a little nasty. I'm going to zoom in to make it bigger for me because, you know, I can't see that well. Drag it over. And Let's see how close we can get. And there it is, right? Go back to my pen. And if you notice, look at your precision right there. There it is. Got it? Zoom back out. All right. Now, let's look for domain. Whoa, my bad. All them icons, lordy. Domain, how far left? Negative infinity. How far right? Infinity. Got it? Range. How far down? Negative infinity. How far up? Infinity. Now, here comes the next one. I think these are the hardest three on the test. People freak out. I love them. You know what this parent function looks like. Do a quick sketch. You know it normally sits right here. But notice, this guy right here says horizontal translation to right. So just come down here and come right here. Just put it here. And then you know you can go to the right. Watch how cool this is. I'm going to pick x equals 6 so I can stick that in there. That gives me square root of 4, which is what? 2. So when my x is 1, 2, 3, 4, 5, 6, I know I got to go through this point right here. So now I can make a very nice curve just like that without a calculator. Wow. Remember, domain for this guy is special. What does he start at? He start at what? 2 goes for infinity. What's the range? The range is what? 0 to what? Infinity. Remember, domain's left, right. Range is what? Up, down. Lots of folks forgetting that. You want to make sure with number 10, look what you got. Don't forget your parent function also. Y equals square root of x. Parent function here. Y equals log x. In your mind, think of a quick sketch. You know he has an asymptote. That's horrible. He has an asymptote that goes right here. This plus 4 simply tells you what are you going to do to that asymptote? Shift it over 4. So come over and redraw a new one. There it is. There it is. Now here comes the magic question. Where do we normally cross the x-axis at? 1. But now we're going to move it over 1, 2, 3, and now we're going to cross right here. Where is it going to cross the y-axis at? Y equals log x plus 4. You stick in a 0 so you get log of 4. Remember, any log of a number where x is less than 10 is less than 1. Simple. Just remember, it's got to go below 1. Your horizontal doesn't change, so we go here. We're going to go 1, so I got to catch it right between here. Once again, I'm going to zoom out real big so you can see exactly what I'm talking about. Okay. Find the mouse. Notice he was at 1. 1, 2, 3, 4. Now it's got to cross at 3, and he's going to come below this guy right here. So let's see how precise we can draw this guy. Asymptote, you can get close, but you can't touch it, right? So that means I can go up, go up, go up, go up, go up, over here, hit here, and turn. There it is. All right. Now, zoom back out. Cool. Zoom back out. Now you can come here and say, what's my domain? My domain is -4 because I don't touch it. That's why this is a parentheses to infinity. My range is negative infinity to what? Infinity. Notice it's still infinity. It's get there slow, but it's going to be going up slowly. Number 11, one of my favorites. I know my function normally looks like, I'm just going to find a spot to draw this on. My parent function is going to look like this, right? Notice he's got to go up 2. That means my asymptote, which is normally here, is going to be here. This guy's special. Simply find your y-asymptote, find your intercept, stick in a 0 here. Let me see if I can find another piece of paper somewhere, something that I can draw that information on, because I know I need this graph right here. So what we're going to do is, if you stick a 0 in here, you get a minus a negative 2 to the negative 4 plus 2, which simply tells you that this guy flips over and that becomes minus 1/16 plus 2, which just means it's got to go a little bit less than 2. So that's easy. Here's my 2. I'm going to go a little bit less than 2. Can't touch that asymptote. Turn down. Here's the one thing also. Where does it cross this this x-axis at? Well, you can let y equal 0, and that's a really cool mathematical concept, because that guy, follow me over here, that becomes 2 to the x minus 4 equals 2 to the 1. From algebra, you should know to cancel that. So x minus 4 equals 1. So x is equal to 1 plus 4, which is what? 5. So now he's going to cross at 5. I'm going to clean this up just a little bit. Give me an eraser. Clean that up a little bit. And he's going to cross at 5. 1, 2, 3, 4, 5. He's going to dive at 5 right there. There we go. Domain. What's your domain? How far left? Negative infinity to infinity. How far? What's your range? Notice, be careful. It goes from what? 2, doesn't touch that asymptote, down to negative infinity. And there you go. Go ahead and save this one. I'm going to pause. I'll be right back with page number 3. Here comes page number 3. A lot of people get nervous because they see this inverse. Don't let it scare you. Do a quick sketch. You know this is what it normally looks like. Oh, horrible. You know this is what it normally looks like. My pad's turned sideways. Sorry. Whoa, 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 whoa. Don't do that. You know this is... Okay, hang on. Let me take a time out for a second. Okay, here we go. You know this guy's normally looks like this, right? He has two asymptotes, horizontal and vertical. If you just look at this, it tells you that you're going to have a what? Horizontal shift of 2, or left, right, sorry, horizontal translation, because this is the opposite right here. That guy tells you you have a vertical shift of 3 up. So all you gotta do is draw your new asymptotes. There you go. To right. There you go. Now you know that it has to come down here and look something like this. Be careful. Find that y-intercept. Let 0 go here. That becomes minus 1/2 plus 3, which is 2.5. So you know he's going to come in here somewhere and catch it just like this. Oops, and you know he's going to be close. That's pitiful, but let's try that again. Try that again. I'm going to go ahead and get it here. Don't touch it, 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 don't touch it. Get close, get close, get close, get close, don't touch it. There we go. Now, what's your domain? Special domain starts at negative infinity. That's how far left. It gets to 2, doesn't touch the 2. That's why you have a disjunction. 2 goes to infinity. There we go. Now you come down here and you have range, and you go from negative infinity to 3, another disjunction, so it goes 3 to what? Infinity. Got it? That's cool. Simple. No big deal. Who's the parent function? Y equals what? 1 over x. Now, absolute value, quick sketch. There it is. Negative sign says what? Flip it. Got it. This says shift what? horizontal shift, left 16, left 16, and vertical is what? 2 up. And you look at this one now, you have a reflection across x-axis, across x, and that's because of negative sign. And you have a vertical stretch. If the number is less than 1, remember, it is what? Vertical stretch. If it's greater than 1, it's a compression. That's just simply slope. I'm going to find my new vertex. I'm going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16. Go up 2. In this case, it's just going to be one step. What's my slope? 1 over 8. So I'm going to go up 1 and over 2, 4, 6, 8. Now let me go and get that that y-intercept. Sticking a 0 here. That gives me minus 16 over 8, because the negative times 16 plus 2, that gives me minus 2 plus 2, that gives me 0. So wow, look at this guy here. He's going to be way over here, which means he's going to be way over here because of the reflection. So notice this guy is very, very, very what? Wide, because it's a compression. Right here I said vertical stretch. That's wrong. That should be a compression, because why? The number is less than 1. If the number is less than 1, compresses. If the number is greater than 1, it stretches, which means skinny fat. Compression is a fat. Skinny is a stretch is a skinny. If you stretch something, you get skinny. Y asymptotes. Guys, a lot of people surprise me here. Anytime you say y-intercept, let x be 0. So all you gotta do is draw a line through all your x's. You're left with minus 1 times 7, so that y-intercept is minus 7. Y-intercept point is 0 minus 7. Same thing here. Kill, kill, bam, bam. 9 times 4, y equals 36 is the y-intercept. Kill this, y equals 6. In this case, f of x equals 6. Y-intercept 0, 6. That only takes 3 problems in what? 5 seconds. You got to know your stuff. Let's pause, get ready for page 4. Oops, sorry I wasn't quite finished, didn't see this bottom part. In behavior, once again, left hand, right hand. Where's it trying to go to? Negative infinity. Right hand, where's he trying to go to? Negative infinity. 2 seconds, got an answer. This guy here, left hand, this is the one everybody miss. Ask yourself, where's he trying to dive down to? He's trying to dive down to 0. Right hand, where's he going to? He's going up to what? Infinity. Alright, given this function, yada 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 yada, now we're about ready to talk and see what it's going to do. Okay. Gonna pause, come back to it, get ready for page. Okay. Number 16 says, given the function, write the inverse. Inverse is very simple. All you gotta do is just switch the numbers. So when you see this guy here, it says what's the inverse? You come down here, you write it as a set, and then you just switch the numbers. I see 2041, 20, comma, semicolon, 41, negative 5342, negative 5342, and I think that last one, let me go check it to make sure. Close that with a brace. Is going to be 84. So that becomes what? 48. Simple. 2 seconds. It's the inverse of function. How you tell if it's a function again? You see if the x's repeat. If they repeat any time, then it's no. And obviously this is a no. Okay, number 17. Couple of things here. What is the family's apparent function from? Y equals x squared. Graph the function. You know it's bowl up. Give the x-intercepts. Show work. X-intercept, you let that be 0 equals. Now let's erase this guy here. They're trying to trick me. I'm going to just back up for a second completely. That's the parent function. Graph the function, which simply says what? Shift 2 left, right? And 1 down. So I got to go 2 left, 1 down. Find my y-intercept, sticking a 0 for x. 2 squared is 4. 4 minus 1 is 3. Alright, but before I get that 3, let's see what that x-intercept is going to look like. That x-intercept says 0 in for y, x plus 2 squared plus 1 minus 1, right? So that gives me x plus 2 squared equals 1. Take the square root. You know that's x plus 2 equals negative 1, or x plus 2 equals 1. Because that guy has to have what? Two solutions whenever you take the square root. So x equals what? Minus 3, and x equals minus 1. Makes sense. Look where they hit. Boom. And boom. Now you got some. No, whoa. I got throwed. Sorry. Now you got a very nice, pretty curve right there. And then don't forget your friend Lowe's line of symmetry. Okay. Show your work. We just did. For my y-intercept, 0 equals x plus 2. Sorry. X equals 0. So that gives me y equals 2 squared minus 1. That's how we got this 3 right here. Describe the end behaviors. Left hand, once again, where's he going? He's going up. Right hand, where's he going? He's going up. Remember, end behaviors, up, down, up, down, up, down. Got it? Graph the inverse of the function. Well, the inverse says find 3 dots and just switch them. You know your vertex was minus 2 minus 1, so let's make it minus 1 minus 2. Got it? You know the other dots was, I had a y-intercept of 3, 0, so now we have a dot of 0, 3. You know you had a dot at minus 1 minus 1, 0, so now you got a 0 minus 1. Now you know you had a dot here at minus 3 minus 1, so now you got a dot at minus 1 minus 3. Cool. So if you just connect all those dots, and let's see what we get. I'm going to just create another axis over here so you can kind of see what's going on. Okay, 0, 1, 0, 3 becomes 3, 3, 0. Minus 1 minus 3 becomes minus 3 minus 1. Minus 1, 0 becomes 0 minus 1. Minus 3, 0 becomes 0 minus 3. This guy here was minus 1 minus 2 minus 1. So now it becomes minus 1 minus 2. And look what happens. It simply just turns on its side. Cool. Is this a function? No. Why not? Because it fails the vertical line test. Wow. This is not quite that important, but it's going to be in a little while, so don't worry about it too much. But you should understand that. 18, bam bam. Negative sign. What do you get? Reflection across horizontal axis. Right? And you have a what? And then you have a horizontal translation of what? 2 left, vertical shift, 2 down. Done. Same thing here. Horizontal shift of what? 4 left and 3 down. be careful. Put this in order. Minus 2x cubed, right, plus 3. That becomes a what? Reflection cross x. That also becomes a vertical stretch because you're looking at the magnitude, not the negative sign, just the number. So technically when you say magnitude, you're looking for the absolute value of it. That is greater than 1, so it's a what? Vertical what? Stretch, right? Now you have a what? Plus 3. That means we have a what? Vertical shift of what? 3 up. Oops, that don't look too good. Shift 3 up. Done. Now, definitions. I want you to go find 2 formal definitions for range, domain, and function. That's the review. I will go back and type in a very nice, pretty copy so you can have the written solutions. I'm going to give you the handwritten ones and the nice and pretty ones. The video is crucial, so go back and look at it. Thanks. Look forward to seeing you guys on Monday. Don't forget, we have ELC, so I won't see you on Monday and Tuesday, but the review will be able to be played. All right. Bye. Love you. Bless you.